Good day everyone. For today's video, we are going to do activity 2 about the thermal conductivity. So the first problem here is the R value for a certain material that is 3.5 mm thick is 2.0. What is the R value if the thickness is increased to 4.5 mm and 1.9 mm? So let's find out. So let's write first the given. The given here is our R1 is equal to 2.0 and our L1 or the initial length is equal to 3.5 millimeter, while our R2 is what we are looking for. So our L2 is 4.5 millimeter. So next is, this is what we are going to do to get the final formula that we are going to use in solving a problem number 1. So R2 is over R1 is equal to L2 over L1. So in here, we are going to do a cross multiplication. So R2 and L1 is equal to R1 times L2 over L1. So since we are looking for the R2, we are going to put R2 in here and we are going to write this R1 times L2 over L1. So the next step is we are going to transpose the given by using the formula. R2 is equal to 2.0 our R1 times L2 is equal to 4.5 millimeter over L1, the 3.5 millimeter. So we are going to cancel out the same unit. We are going to calculate this one. 2.0 times 4.5. So, close open parenthesis. 2.0 times 4.5 parenthesis is equal to 9 over 3.5. So now we are going to divide this one and to get the final answer. 9 divided by 3.5 is equal to 2.57, 14, 28, 57, 143. So we're going to write a 2.57 only. So this is our final answer for letter A. So now let's move to letter B. So we're going to write the given, the R1 is equal to 2.0 and L1 is equal to 3.5 millimeter, and of course our R2 is what we are looking for, so let's move to L2 is equal to 1.9 millimeter. So since we find out the final formula that we're going to use, so let's use again the formula that we use in letter A. R2 is equal to R1 over times L2 over L1. So let's derive the given. R2 is equal to 2.0 close parenthesis, open parenthesis, 1.9 millimeter, our L2 over L1, the 3.5 millimeter. So we're going to cancel out with the same unit. Cancel and cancel. So we're going to multiply this one first. 2.0 times 1.9 is equal to 3.8. Copy the L1, 3.5. So to get the final answer, we are going to divide 3.8 and 3.5. So 3.8 divided by 3.5 is 3.8 divided by 3.5 is equal to 1.0857 1428.571. So we're going to round off. So this will now a 1.09. So our problem number 2 in thermal conductivity is, what is the rate of a heat flow through a glass window that is 2 meter times 3 meter and 1.4 centimeter thick if the outside temperature is 25 degrees centigrade and the inside temperature is 27 degrees centigrade? Q is equal to 0.84 joules per second meter centigrade. So the given here is Q is equal to 0.84 joules per second meter centigrade, and our delta T is equal to 27 degrees Celsius. So of course we're going to subtract this one to 25 degrees Celsius. So 27 minus 25 is equal to 2 degrees Celsius. So this is our final temperatures, and our area here is 2 meter times 3 meter. So of course we're going to multiply 2 meter times 3 meters, so we have a 6 meters squared for our area, and our length is equal to 1.4 centimeter. 1.4 centimeter. So of course, we are going to convert this centimeter to meter. So 1.4 centimeter times 1 meter over 100 centimeter. So we have a 0.014 meter. So this is the formula that we are going to use in solving problem number 2. Delta Q over delta T is equal to Kelvin times area times delta T over length. So now we're going to derive the given. .84 joules per second meter centigrade times our area is 6 meters squared and our delta T is 2 degrees Celsius over length, which is the 0.014 meters. So we're going to cancel out the same unit. Cancel out this out. And we are going to calculate 0.84 joules per second meter centigrade and 6 meters squared times 2 degrees Celsius. So let's calculate 0.84 times 6 times 2 is equal to 10.08. 10.08 joules per second over 0.014. So to get the final answer, we're going to divide the 10.08 to 0.014. 10.08 divided by 0.014 is equal to 720. So our final answer is 720 joules per second.